We're going to work with some compound interest here. The first example is asking us to determine the values of I and N for each annual rate and time. Now remember, I is the interest rate per compounding period and N is the total number of times it will compound. So the first example is 12.5% per year, and it's compounding annually, which means once per year. So our I value is just going to be the 12.5% in decimal form. Now I could divide that by 1, but that's just going to give me 0.125. My N, it's compounding every year for 6 years. The N is just equal to 6. It's going to compound 6 times in total. For the next one, we have 15% per year, and it's compounding semi-annually. That means twice per year, 2 times per year. So if we look at that, then our I value will equal 0.15. So that's per year, but we need to cut that into 2 equal pieces to get how much, what percent is spent over half a year, or charged or earned over half of a year. So that works out to 0.075 is the value that we would use for I. Now again, the N value is your total number of times it's going to compound over the course of the term. So if it's compounding 2 times each year for 3 years, our N is 2 times 3. So twice per year for 3 years. Our N would equal 6 when we go to do our calculations here. All right, the next one, it's compounding quarterly. That means it's 4 times per year, 4 times. That's X is not like an X, it's times. 4 times per year. So I want to take that annual rate, my I value will be the annual rate, 0.036, and then we're going to divide that into 4 equal pieces here. And likewise, the N, it's compounding 4 times every year for 8 years. So it'll be 4 groups, 8 times. And that gives us 32 here. This should be 0.009. Now don't be alarmed if your calculator gives you something weird for that I value. Mine had a 9 and then a little negative 0.3, which really means 9 times 10 to the exponent negative 3. Move that decimal 3 places to the left. So if it was at the 9, it would go 1, 2, 3, and that's how I get 0.009 out of that. But don't worry about that because we're going to add 1 to those values when we do our calculations. Now the next one is compounded monthly, so that's 12 times each year. So our I value would be the annual rate, 0.06, and we're going to divide that into 12 equal pieces, and that gives us 0.005 there. Our N, we want the total number of times it's going to compound. So it's compounding every month for 30 months. So N is just equal to 30. So notice the time frame here was in months versus the other ones which were in years. So you just have to think about that logically. How many times will it compound in total? All right, the last one here. This is a common interest rate for store credit cards, like our Canadian Tire card or a Best Buy card. Those have fairly high interest rates on them, and that's how people get into trouble with their debt on credit cards. So keep in mind, never charge anything to your credit card that you cannot afford to pay off at the end of the month in some way, shape, or form. And it's being compounded daily, so we want to take that annual rate and divide it into 365 pieces. Now, I'm not even going to take that to a decimal. When I do my calculation, I'm just going to use this exact value here in my calculations for that. And my N is, I have 90 days and it's compounding daily, so it's going to compound 90 times. All right, so let's put this to work and see what we can do for calculations. We want to determine the amount, so that's the A value, at the end of our time frame of an investment of $50,000. So amount is what we're trying to figure out. Our investment, our principal amount of our investment is $50,000. And its rate is 6% per year compounded quarterly. So we're going to use that to figure out I. We're going to take that annual rate, 0.06. Remember, just take your percent, divide by 100, and it's compounding quarterly. That's 4 times per year. Now you can either do that calculation or just leave it like that. If you do the calculation, you're going to end up with 0.015, and then we're compounding quarterly, so 4 times every year for 5 years. So quarterly, 4 times per year for 5 years, that gives us a 20. It's going to compound 20 times overall. Now we're going to actually use our compound interest formula, which looks like this. It's that exponential formula. The P is your initial value, so $50,000 is what our investment starts with. We're going to have 1 plus the I, which this one worked out nice, but if it doesn't, I just use my fraction form so I don't have any rounding errors with it. And my N is the total number of times it compounds will be a 20 there. So on my calculator, I'm going to actually calculate. Some calculators can handle that all as one calculation. Mine, it's a little bit more complicated, so I'm going to follow BEDMAS. I'm going to actually add 1 to my value of I that I calculated over to the left there. So I'm going to add 1 to that, and then I'm going to take that to the exponent. So BEDMAS says brackets, then exponent. So that to the exponent of 20, and then I'm going to multiply that by 50,000. And I get $67,342.75. So after 5 years, we have a total of $67,342.75. The amount of interest just for leaving your money in the bank would be the difference between that amount and the $50,000. So you've actually earned $17,342.75 for doing nothing, just leaving your money in that account. Kind of nice. And that's how you're going to save for your retirement as time goes on here. Good thing you guys are young. You should start early because you've got the power of time on your side when it comes to saving for your retirement. All right, example 3. How much money will you have at the end of the term? So how much money will you have at the end? So A is what you're trying to solve for. If $10,000 is invested, so the principal amount is $10,000, is invested at a rate of, so 7.2%, that would be 0.072, and it's compounding monthly. So I want to divide that into 12 equal pieces. So 0.072 divided by 12. This, again, does work out nicely. If it didn't, I would just leave it in its fraction form there. Number of times it's going to compound. It's monthly for 10 years. So 12 times per year for 10 years is 120 times it will compound. So let's see how much $10,000 will grow to in 10 years here. So P 1 plus I to the exponent of N. $10,000, 1 plus 0.006 to the exponent 120. And calculate that in one step. And we have now more than doubled our amount of money here. $20,500.18. So we have gained $10,500.18 in our investment. All right, next one. What principal amount was invested at 9% per annum? So this time we're asked for the principal amount. That's our unknown. Principal is unknown this time. Invested at 9% per annum. I'm going to put A here next, and then I. So 0.09. It doesn't really matter what order you state these in. Compounded semi-annually. So I got to divide that into 2 equal pieces here. So that's going to equal 0.045. It accumulates or adds up to or ends up with $6,123.88. And in 42 months. Now we have to be careful here because it's compounding semi-annually in 42 months. We need to figure out how many times it's going to compound. So it compounds every half of a year, which is every 6 months. So I'm going to see how many groups of 6 fit into 42 months here. how many times will it actually compound? How many groups of 6 months can I make out of 42? And that gives us 7. So it's actually compounding 7 times. So this is kind of a trickier question for sure. I'm going to fill in my formula with what I know. And then we're going to work on solving. So the A is what we know this time. So that makes this question different. And we want to solve for the P. We're going to have 1 plus 0.045 here to the exponent of 7. Now to get P by itself, it's being multiplied by all of this part here. So what we're going to do is divide both sides by that bracket. And I'm just rewriting 1 plus 0.045 is just 1.045. So I'm going to divide that out on this side, which means I also have to divide it out on this side of the equation. And that will help us solve for P. So P will equal whatever that calculation is. So 6123.88 divided by 1.045 to the exponent of 7. And that gives me $4,500. So we started with an investment of $4,500. And that rounds to like even $4,500. All right, so that's the principal amount there. Now we have some more examples, but I'll start those on another video.